Have you ever just stared at a gigantic number and your brain just shuts down at the thought of doing long division? Well, what if I told you there's a family with a secret, a set of math tricks that can solve huge problems in, like, seconds? Today, we're going to learn the divisor family's secrets. Okay, take a look at this. Over 4 million oranges. Can they be divided perfectly into boxes of 3? I mean, you could grab a calculator or a pencil and paper and be there for a while, or you could use a trick that solves it in less than 10 seconds. Stick around, because we are going to solve this exact problem without touching long division.
So the secret, it lies with the divisor family. We're going to meet 4 brothers today, and each one is a master of their own set of mathematical shortcuts. They call them divisibility rules, and they're going to be our guides, turning these complex division problems into really simple, quick checks.
So what is a divisibility rule? Put simply, it's a shortcut. It's a super fast way to see if one number goes into another one perfectly, with a remainder of 0. It saves you from all the heavy lifting of actually doing the math. All right, our first stop is the Smile Toy Factory, where we meet Windsor Divisor. He's the manager here, and his secret is all about keeping it simple. Windsor's rules only need you to look at one thing, the very last digit of a number. That's it. Let's see how this works.
Windsor's rules are, just super intuitive. The rule of 1, easiest one there is. Every single whole number is divisible by 1. For the number 2, you just check if the number is even. For 5, the number has to end in a 5 or a 0. And for 10, the simplest of them all, it just has to end in a 0. Easy peasy.
And you can see how powerful his method is right here. For 264 robots, we just look at the 4. It's even, so yep, divisible by 2. For 875 dolls, that 5 at the end instantly tells us it's divisible by 5. And for the 6,741 marbles, the 1 at the end tells us it's not divisible by 2, 5, or 10. It really is that simple, just a quick glance.
Next up, we're at his brother Connor's fruit shop, and his method is totally different. See, Connor doesn't look at the last digit. He wants us to add all the digits of a number together. He calls it the sum trick.
Hey, remember our massive orange problem from the beginning? Here's the solution. Instead of dividing that giant number, we just add up all its digits. So 4 plus 1 plus 7 and so on gives us 36. Now, is 36 divisible by 3? Of course, but here's the best part. If you weren't sure, you can just do the trick again. Add the digits of 36. 3 plus 6 equals 9. And since 9 is divisible by 3, so is our original 4 million plus number. Incredible, right?
And once you've mastered Connor's rule for 3, well, his rule for 9 is a total breeze. It's calculated the exact same way. You add up all the digits, but this time, you just check if that sum is divisible by 9 instead.
Let's try it with 361,017 bananas. We add the digits, and the sum is 18. We all know that 18 is divisible by 9, so the original number is 2. Connor can pack up all his bananas in boxes of 9, and there won't be a single one left over. The sum trick is a seriously powerful tool.
All right, time to head out to the country to meet the third brother, Trevor, on his organic farm. Now, Trevor's method is kind of like a mix of his brothers. He doesn't look at just one digit, but he doesn't use all of them either. Trevor's rules focus on small groups of digits right at the end of the number. So here's the key difference. For the rule of 4, you only care about the last 2 digits. If that 2-digit number can be divided by 4, the whole number can. For the rule of 8, you just expand that idea a little. You look at the last 3 digits. If that 3-digit number is divisible by 8, you're good to go. Let's see this in action on the farm. Trevor has 344 sheep. We just ignore the 3 and look at the 44. Since 44 divided by 4 is a perfect 11, the number 344 is divisible by 4. Now for his 2,856 chickens, we look at the last 3 digits, 856. A quick check shows 856 is divisible by 8, so the entire number is 2. All his animals are going to be perfectly grouped. Our final stop is Divisor Diner, and it's run by the oldest brother, Taylor. His rules aren't exactly new. They're more like family recipes. He cleverly combines the tricks of his younger brothers to solve even more problems. This is where it all comes together. Taylor's rule for 6 is a perfect family recipe because, well, 6 is just 2 times 3. So that means for a number to be divisible by 6, it has to pass a 2-part test. First, Windsor's rule for 2, and second, Connor's rule for 3. If it passes both, you're golden.
Look at Taylor's 108 olives. First up, Windsor's rule. Does it end in an even number? Yes, it ends in 8. So it's divisible by 2. Check. Next, Connor's rule. What's the sum of the digits? 1 plus 0 plus 8 is 9. Is 9 divisible by 3? Yep, check. Since it passed both tests, 108 is divisible by 6.
This is such a great example of how Taylor combines the family tricks. See, since 12 is 3 times 4, his rule for 12 combines Connor's rule for 3 and Trevor's rule for 4. For his 144 blueberries, the sum of the digits is 9, so it passes the rule of 3. The last 2 digits are 44, which passes the rule of 4. Since it passes both checks, 144 is divisible by 12. Every tart will be perfect. So why does all this matter? I mean, these aren't just party tricks. They are fundamental tools that make math so much easier. You can use them to simplify fractions in a flash, quickly check if a number is prime, and apply them in tons of everyday situations. They give you a deeper feel for how numbers actually work.
So we've met the whole family. Windsor's simple last-digit check, Connor's powerful sum trick, Trevor's group of digits method, and Taylor's clever family recipes. So the only question left is, which one of these amazing shortcuts are you going to try out first?